Okay, Roland, I'm sorry. I've had like a crazy day. So I pulled most of the problems off of there. So the first one, remember that the derivative of ln u is 1 over u times u prime. So u is going to be whatever was originally in your ln. U prime would be the derivative of that. So this is the same as the ln of x to the 5 halves, because remember, a square root counts as a 2. So when you take your derivative of that, y prime, that would be the derivative, would be 1 over x to the 5 halves times the derivative of x to the 5 halves. So remember the way the derivative works, you times the 5 halves down to the front, and then you take away 1. So if I'm doing 5 halves minus 1, that's 5 halves minus 2 halves. So that would be 3 halves. So then from there, you would have 1 over x to the 5 halves, 5 over 2 x to the 3 halves. And you should notice these x's are on top, these are on bottom. So that means that you would need to subtract. So if I do 5 take away 3, there's going to be 2 halves left over. But think about if you have x to the 2 halves left over on the bottom, really that's just the same as 5 over 2x. So you're subtracting those fractions, and it just happens to work out that it's 2 over 2, which is the same as 1. So that would be your answer. Okay, second one, you're going to need to do product rule. So your u is going to be x. Your v is going to be x squared plus 1 to the 1/2. Remember, the 1/2 comes from the square root. So then u prime would be 1. V prime, this is how I set up the product rule. I don't know if your teacher shows it differently, but basically this is the first part of the product and the second part. So you split it up, take the derivative of each one. So that 1/2 times is down to the front. X squared plus 1 is now to the negative 1/2, because I take basically 2 halves away to get to the derivative. Then you times by the derivative of the middle, which would be 2x. Then hopefully you can see that the 1/2 and the 2, those are going to cross out. So your derivative would be uv prime, that's this diagonal, plus vu prime, which is this diagonal. So it would be x times x squared plus 1 to the negative 1/2, plus, and then 1 times x squared plus 1 to the 1/2. But then remember, these 1/2s are really just square roots in disguise. The negative 1 is going to move down to the denominator though. So you would have x squared on top over the square root of x squared plus 1. And then that x squared plus 1 is just going to stay in a square root like that. You could simplify it different ways. I don't know exactly what your teacher would be looking for. Okay, next one, you would rewrite this whole thing basically as x squared minus 1, x squared plus 1, all to the 1/2. So when you take the derivative of that, you'd be doing chain rule. So you'd multiply your 1/2 down to the front. You'd change the power on it, x squared minus 1 over x squared plus 1. You'd make it to the negative 1/2, because if it was to the 1/2, when you take away 1, you get negative 1/2. Then you would need to multiply by the derivative of this, which would be quotient rule. So hopefully you learned that in class, but it would be the bottom times the derivative of the top, which would be 2x, minus the top, x squared minus 1 times the derivative of the bottom, all divided by the bottom squared, which would be x squared plus 1 squared. Okay, and then you could probably times the top of that out and then combine like terms. So on the top here, 2x times x squared would be 2x cubed plus 2x. Then when I times in back here, I'd have negative 2x cubed minus 2x. And it looks like actually all of that is going to cross out to be 0. So just be 0.
Dang.
Yep. Okay. Next one. Remember that the derivative of ln x is 1 over x. So if I pull the 12 out to the front, then that would really just be 12 times the integral of 1 over x dx. Remember, you can always pull constants out. So the antiderivative of 1 over x, remember, that's just reversing a derivative. So if I'm starting here, the integral would be ln x. Remember, you put it in the box. Then we're going to plug in 5, plug in 1. 12 is still on the outside. When I plug in 5, I'd have the ln of 5. Plug in 1, I'd have the ln of 1. And then remember, you take those pieces, you subtract, multiply by 12 in the front. So you'd have 12 times the ln of 5 minus the ln of 1. Now, one of the product rules for logs is that if you have the log of a minus the log of b, you can rewrite that as the log of a over b. So probably your teacher would expect you to know that and do 5 over 1 in the same log. So you'd have 12 log, ln, because it's a natural log, and then 5 over 1, which is the same as just 5. One other property your teacher could use is that if you have a number here in the front, you can always pull that up and make it an exponent. So they could also take this 12 as the coefficient, and they could pull it up and make it the ln of 5 to the 12. I don't know if your teacher would do that, but they could. Okay, next one, bottom right, we're doing u substitution. I remember we went over this summer. My u is going to be the bottom part, x squared plus 4. So then my du would be 2x dx, which means that, remember, you solve for dx would be du over 2x. Okay, from there, remember, you're going to rewrite your integral in terms of all this u stuff. So you'd have the integral of 8x over u. And then when I get to dx, I'm plugging this in, du over 2x. Hopefully you can see that 8x divided by 2x is going to leave a 4, 1 over u du. So this crosses out to a 4, but I can pull it out to the front. And then 1 over u, the integral of that, hopefully you remember, is ln u. But then remember, I don't want u, I want to go back to this original crap. So you would have 4 ln x squared plus 4. And then you would plug in, my upper boundary was a 4, my bottom boundary was a 0. So if I plug in a 4 here, I'd have 4 squared is 16 plus 4 more is 20. That would be the ln of 20. Then if I plug in 0, 0 plus 4 would be the ln of 4. Then remember, technically you should have your f of, sorry, I'm trying to like write over Jeremy here. So then you take these two things, remember you subtract. If it's ln 20 minus ln 4, remember that rule, you divide them if you're subtracting. So that would be 4, sorry, this is not a lot of space, 4 ln 20 minus ln 4. But then these divide out to be 4 ln 5. Remember, your teacher could also pull that 4 up as an exponent, just kind of depends how they want to see it. Okay? All right, the other two that I saw on your review, or 3, are also u substitution. Okay, the integral of e to the u du is e to the u again. So you're just going to have to do u substitution there. So I'm going to let my u be the exponent. If u is 5x minus 3, then du, remember this is always just the derivative, would just be 5 dx, which means that dx would be du over 5. Remember we talked about your solving for that by dividing that to the bottom. So rewrite your integral. That would be e to the u du, and then my du is divided by 5. Remember, we also talked about that anytime this is a coefficient, you can pull it out to the front. So that would really be 1 over 5, and then the integral of e to the u. But remember your rule, e is the only function that when you integrate, you get e again. So you would have 1 over 5. In the brackets, you'd put e to the u, but I'm going to go ahead and pop the 5x minus 3 back in. Then remember, my upper boundary was e. My lower boundary was f of 1. So then from there, you'd take your e, plug it in right there. So you'd have f of e would be e to the 5e minus 3. Plugging in 1, you'd have e to the 5 times 1 is 5 minus 3 is 2, e squared. Then you would take these two things, subtract, keep your 1/5 on the outside. So it'd be a 5th e to the 5e minus 3 minus e to the 2. Okay, and I don't know that you could really simplify that much further. Okay, this one, the antiderivative of 2 to the x. Huh?
Phone's dying.
Oh, okay. The integral of e to the x is e to the x again. 2 to the x would be that over ln 2. So other than that, it's basically exactly the same. You'd have your 2, you'd have your -1. Plug each of them in, then subtract. So f of 2 would be 2 to the 2, which is 4. F of -1 would be 2 to the -1, which would take your 2 down to the bottom. So it'd be 2 to the 1 power, but it'd move to the bottom and be a 1/2. Then remember, you take 4 minus a half, and then you just put your over ln 2. Remember, you only have to divide by that if it's not a base e. Okay, last one. Hopefully my phone survives. Okay, my u I'm going to pick to be my sine x, which means that du, the derivative, would be cosine x dx. Then remember, I got to get dx by itself, so that cosine is going to divide to the bottom. Du over cosine x. Then from there, I'm going to take this, substitute here, and then my sine x is going to turn into a u. So it'd be the integral of, was that 2 to the u cosine x, and then my dx is now a du over cosine x. Now remember, if there's numbers, okay, like here, we could pull that over 5 out to the front, but if it's a cosine x, it has to cross out. If it doesn't, you did something wrong or you picked the wrong thing for u. Then remember, the integral of 2 to the u is 2 to the u again, but you put a 1 over ln 2 in the front. So then it'd be 1 over ln 2, and then it'd be 2 to the power of sine x. And then also remember, you would always have a plus c, because you have that constant of integration. So I think up here when we integrated, oh wait, never mind. Okay, the difference is you're going to have the plus c if you do not have endpoints on your integral. Okay, but you will not have a plus c if you do have endpoints. So that's kind of the difference, okay? So good luck on your test tomorrow. I hope you have time to watch this beforehand. Study. I'll send you a picture of the front and the back in case this video was a little all over the place. So good luck. You can do it.
Good luck.